Welcome to Career Guidance Max playlist. Today we are going to see problem number 3 in Lagrange's multiplier method. So the question is x square minus y square minus z square into small p plus 2xy into q is equal to 2zx. So this equation I am going to compare with our Lagrange's form. What will be our Lagrange's form? Capital P into small p plus capital Q into small q is equal to right hand side values I'm going to consider R. Okay. So now this Lagrange's general equation and a given problem you can compare. So you will get capital P Q R because in your problem they will give small p small q and right hand side equal to one term. Rest of the term we can consider capital P capital Q capital R based on your Lagrange's general linear equation form. So you will get capital P equal to x square minus y square minus z square and q equal to 2xy, and the right hand side term we have to consider r, that is 2zx. If you want to solve this problem, enough to solve the subsidiary equation. What is that subsidiary equation? Dx divided by p is equal to dy divided by q is equal to dz divided by r. So in the subsidiary equation, I am going to substitute capital P, Q, R. So that I will write dx divided by x square minus y square minus z square equal to dy divided by 2xy and equal to dz divided by 2zx. So as I said in last video, in multiplier method we have to choose two multiplier and different multiplier, that is. So if you are applying different multiplier you will get a C1 C2 answer. Okay va? So if you want to find that C1 C2 now, here we have to apply multiplier term or grouping method or some other term. So why I taken this problem? This problem will be differ when compared to previous Lagrange's method problems. This one is a very important one and different problem also. Here I will follow one new method. You should follow that new method while solving this problem. Okay. First I am going to take the multipliers x, y, z. First I am taking the multiplier x, y, z. I am going to apply the operator plus operator. Already you know that why we are applying plus operator, because we have to convert denominator equal to 0, then only we can able to find the answer. So directly if you are adding denominator term now, you can't get 0. Already you know that why it is. When adding direct term it is 0 now, your multiplier will be 1 first multiplier. Or I am applying xyz multiplier now, when adding after applying xyz it gives 0 now, your multiplier will be xyz. Like that we have to choose. But here I am applying now xyz. See, when applying xyz in your subsidiary equation, can I get denominator equal to 0? Not possible. But here I am going to apply another method, one more method. So in numerator add x into dx divided by plus y into dy plus z into dz equal to x of x square minus y square minus z square plus y into 2xy plus z into 2zx. After that, usually we are writing any ratio, but here we can't able to write like that because you can't get the answer. So again, here you will have three values dx, dy, dz. Again I am going to equating the term, any one term, dy or dz. I am taking dz, equating to dz divided by 2zx. This is one ratio we are forming. After applying multiplier, again we are equating with one term within that, dz divided by 2zx. Okay. So now x dx plus y dy plus z dz divided by, add these terms. Okay. Now in denominator term I am taking x commonly outside and I am writing x square minus y square minus z square, okay, in first term, plus second term I am taken outside x, you will have y into 2y, that is I am writing 2y square, and plus here I am taking x outside, so that z into 2z, I'm writing 2z square. And right hand side equal to dz divided by 2zx. Okay. So both side I'm going to cancel this x. And this 2 I'm shifting to left hand side numerator term. And here x square minus y square minus z square plus 2y square plus 2z square. I'm writing this is 2 of x dx plus y dy plus z dz divided by, I'll write x square plus y square, because 2y square minus y square will get plus y square. 2z square minus z square will get plus z square. And right hand side equal to dz divided by z. I shifted 2 to left hand side numerator. 2 of x dx plus y dy plus z dz and divided by x square plus y square plus z square. So after this, then now multiply with 2x dx, 2y dy, 2z dz divided by x square plus y square plus z square is equal to dz divided by z. Okay. This 2x into dx plus 2y into dy plus 2z into dz, I'm going to write differentiation of x square plus y square plus z square divided by x square plus y square plus z square is equal to dz divided by z. Now you can differentiate this term, you will get above term. When differentiating x square, you will get 2x dx. When differentiating y square, you will get 2y dy. When differentiating z square, you will get 2z into dz. So this value we can write in the form of d of x square plus y square plus z square. Now I am integrating on both sides. Differentiation of x square plus y square plus z square divided by x square plus y square plus z square is equal to dz divided by z. Both sides we have to integrate. Okay. So here I am going to apply one formula. So integral of 1 by x into dx equal to, I am going to apply log x, because integrand term also x, your function also in term of x in denominator 1 by x form. So see in your integral of differentiation of x square plus y square plus z square, your integrand term also x square plus y square plus z square, your term also x square plus y square plus z square, so that we can apply log of x square plus y square plus z square formula. Okay, and right hand side 1 by z into dz we can write log z. For our convenient, I am taking the constant log c1. Why we are taken log c1? Log for commonly you will have log, so we can cancel easily. But why we are taken c1? Already I told in PDE, whenever in your integral there is no limit, we have to put one constant. So that here I taken c1 because first value we are finding. So I'll take c1. Now I'm writing this term log x square plus y square plus z square, and the right hand side this log z I am shifting to left hand side, minus log z equal to log c1. Okay, here I am going to apply log of a minus b equal to log a minus log b equal to, we can write log of a by b. So according to that I am writing here log of x square plus y square plus z square divided by z equal to log c1. Okay, now we can take exponential on both sides, we will get c1. When taking exponential, log will cancel, you will get c1 equal to x square plus y square plus z square divided by z. Is this your c1 answer? Similarly, we have to find c2. c2 how to find? Again, you can see your subsidiary equation dx divided by x square minus y square minus z square equal to dy divided by 2xy is equal to dz divided by 2zx. Already we find one value of c1 based on xyz multiplier we applied and equating to one term. Now here I am going to apply grouping method. See your subsidiary equation, second term and third term, dy divided by 2xy, dz divided by 2zx. Both the terms are having 2x. We can cancel that 2x. You will get dy divided by y, dz divided by z. Simply we can integrate, we will get the answer. Okay. So now I am going to find based on this equation, second one by grouping method. I am taking dy term and dz term. Dy divided by 2xy equal to dz divided by 2zx. Both the side I cancel 2x. You will get dy divided by y and equal to dz divided by z. Integrating on both sides. When I am integrating this, dy divided by y and integral of dz divided by z. So when integrating this, we will get log y. 1 by y into dy is equal to log y. 1 by z into dz equal to log z. For our arbitrary constant, I am writing log c2. Already I told why we taken log. Commonly we can eliminate log. That's why I taken here log. c2, there is no limit in our integral in PDE. We have to put one constant. That concept we applied here. Then I am writing log y. I shifted this log z to left hand side. I will get log minus log z equal to log c2. Okay. So after this, here I am applying the formula log a minus log b equal to log of a by b. In that manner, I written log of y by z is equal to log c2. Okay. Now, both sides you can take exponential. Log will cancel. We will get c2 equal to y by z. Is this your second answer? Both answers are different. Now I am going to write the general solution. The general solution is phi of c1 comma c2 equal to 0. So the pi of c1 is already we know that x square plus y square plus z square divided by z, comma c2 is y by z is equal to 0. Is this our final answer? Okay, this sum will be differ when compare previous problems. So in this section I can solve more problem, different problem only I will solve. Remaining one you can refer the notes. Okay, very simple one, Lagrange's method. If you know Lagrange's method, you can able to get 8 mark. Definitely in university you will get 8 mark. At least the question paper will be tough now. Definitely you will get one question from Lagrange's, but in this one part will be easy. You may score 4 marks and rest of the values depend upon your mindset. If you are able to equating the term and determining the denominator term equal to 0 now, you can able to solve. Otherwise it's difficult. Okay, thank you pa. ஸோ டவுட் இருந்தால் கமெண்ட்ஸில் டெக்ஸ்ட் பண்ணுங்கப்பா. ஓகேங்களா? ஸோ டெஃபினட்டாக ஐ வில் கிளாரிஃபை யுவர் டவுட்ஸ் இன் Lagrange's method because Lagrange's method is important one. Okay, so in this video I solved one problem, difficult one. Upcoming videos also we are going to try to make it as a difficult problem solving method. Okay, so subscribe our channel, share it to your friends.